Hello and welcome. So this time I'm gonna talk about the Leetcode pattern, and it's gonna be the first pattern, difference array. And I've already prepared the links, and you can check the links from here, and you can check all um, the code for those questions. And basically for this one, I'm gonna prepare a tutorial that difference array can solve the first pattern that is called 1D difference array. And basically we can use this 1D difference array directly. It's just like using a formula to solve the questions, because if you solve one question, definitely those 10 questions gonna be exactly the same. So if you click here, yeah, you can just go inside the question, and you can check what is the Python code looks like. Yeah. So for me, I'm gonna start the first question. It is this one. So let me just search this question, and yeah, so we're gonna just solve this question first. So let me just copy it. Yeah, so definitely I'm gonna solve 10 questions like that, and basically we just need to use a formula. So the formula gonna also be simple, because we don't need to think about it, why the formula works and how to use it, because definitely the description from the problem is directly tell you how to do it, and you can directly use the formula. So the difference array, so this 1D difference array, normally it has a start and add position, and it has a start and add position. So for the start position, we're gonna use a +1, and for the add position, we're gonna use a -1. Yeah, because for such problem, we just need to calculate how many overlaps. So for example, here there are 2 overlaps, here there's 1 overlap. Yeah, so if there's more than 1 overlap, basically in this areas, we're gonna count it. We're gonna count how many overlap points. Yeah. So the difference array can solve the return type. Normally, if it is a number, we had better use a difference array because it is much easier. So if it is we are going to return an array of intervals, maybe the sweep line is better to code. Yeah. So for this idea, so for example, we have 3 and 6. So at position 3, we're gonna have a +1, and at position 6, we're gonna -1. So inside of the array, we're gonna define from the beginning. We're gonna define 0, 0, 0. Yeah. Now what are we gonna do? If we have a 3 to 6, so this is a 0, 1, 2, 3. We have a +1. So 4, 5. Let me prepare the 6. So 4, 5. This is 3 index, 4, 5, and 6. Yeah. So for the index 6, this 6 is included. Normally we're gonna check if this is included or not. So if this 6 is included, what are we gonna do? We're gonna prepare 6 plus 1 to 7. This is 7. There's another 0. Here gonna be a -1. And similarly for all others, for example, if we have 1, 5, so at position 1, we have a +1. At position 6, 5 plus 1, 6, we have a -1. Yeah. Then we're going to accumulate all the values. Let's see what's going to happen. This is 0, this is 1, this is 1. This is just a prefix sum. So from here, it's going to be 2, 2, 2, 1, and 0. Now as you can see, definitely we use the on time to solve the problem. Otherwise, we're going to use the on square time. Yeah, so this is why we're going to use the difference array. Yeah, so if we only have 2 intervals, as we can see that, so from the interval from the index 1 to 2, there's a 1 overlap, but from 3 to 5, index 3 to 5, there are 2 overlaps. And for the index 6, there's 1 over. Yeah, for the index 6, there's 1 overlap because this is index 6. So this is the idea of how to solve the problem. Similarly for the 4 to 7. So after that, we just need to check all those numbers. If it is more than 0, we're gonna count it. So how many numbers? Yeah, currently from 1 to 6, for those two, it's going to be 6 numbers. As you can see, there are 6 numbers, which is more than 0. So this is going to be the solution for the problem. Yeah, I just explained how to solve it. And for all other questions, I will not explain the principle. We just need to use the formula to solve the problem. So, yeah. So for this one, normally we're going to check what is the maximum add precision. So it is 100 because this 100 is also included. So we're going to use 102. Yeah, because the end precision is included. If it is included, normally f should be 0 times 101, but this add is included. We need to prepare another precision for our difference array. This is just for easy calculation. We're going to use 102. Yeah. Now we just need to use the formula to solve the problem. So start and inside the nums. So for the start, we're going to use the +1, and for the add +1, because this is included, we're going to use the -1. Now I'm going to calculate the prefix sum. So in Python, we can use the list accumulate with the f. Now I have prefix sum. I just need to return the sum of all the values which is more than 0. So for this number, it is more than 0. So for n inside the prefix sum, yeah, I just need to count how many positions which the number is more than 0. Now let me just submit, run it first. Yeah, let me check what is wrong. Yeah, it should be 7. Yeah, because I forgot to type there's a typo. It should be start +1 and add +1 -1. Yeah. Now let me submit it to check if it works. As you can see, it works and it's pretty fast because this is a ON solution. Definitely you can use ON square to solve it, but that is just the brute force because we're going to use the new pattern. It is called 1D difference array. So the 1D means we're going to just prepare a 1D array. So this is the prefix sum of this difference array, and we can use the prefix sum to solve the problem. So first of all, we have the difference array, and secondly, we're going to calculate the difference array, and thirdly, we're going to finish the prefix sum of the difference array, and finally, we just need to check. So because this array going to be the overlap. Yeah, so this is for the first question. So now let's go over to the second question. So let me check what is the second question. So the second question going to be this one. Yeah, 1893. Let me find this one. 1893. Yes. Yeah, so if we solve the first problem, definitely the second problem is going to be exactly the same, because those 10 problems will be exactly the same. We just need to be familiar with this kind of a pattern. So this problem is going to be check if the integers in the range are covered. So yeah, it's also the same. We have such kind of intervals. We just need to check if inside the range left to the right, if it is covered. So for example, this is the left and this is the right, as we can say this is covered. So this is also a difference array problem. Yeah. Now let's just use the same pattern to solve the problems. So we're going to use the f array. This is going to be the difference array. It's going to be 0 times. So the right value is 50 because this right is also included. So it's going to be 52. Now we're going to check the start and the add precision inside the ranges. So f start is going to be plus equal to 1, and yeah, I forget to print s every time. Every time I just print the end precision. I don't know why. So for the end, it's going to be e plus 1 minus 1. Now we are going to calculate the prefix sum. So it's going to be the same formula. It's going to be list accumulate with the difference array. Now we get the prefix sum. We just need to check if they are equal or not. So it's going to be the sum of this number n more than, yeah, so let me just use the prefix I more than 0 for I in range left and right plus 1. equal to right minus left plus 1. Yeah, so this one is just for checking the overlap areas, so the length of the overlap and how many overlap areas. And this is just inside of the range. Yeah, if inside of the range it is air overlap areas, for example, this is air overlap areas, it is always be overlap because it has at least one number inside of the range. Yeah, if they are equal, we're gonna return true, otherwise we're gonna return false. Now let's just check that. As you can see, it works. Now let me submit it. As you can see, it passed the testing cases, and it's pretty fast because this is just an ON solution. Yeah, so this n is the maximum value of the right. Yeah, so the right gonna be 50, so we're gonna use the 52. Yeah, now let's just continue to check the next question. So the next question, let me check, it's gonna be 495. So let's just go to this question, 495. Yeah, so it is called Teemo Attacking. So I didn't play this kind of. Yeah, I don't know the English name, what it's called, but I remembered maybe sometime a long time ago I played this kind of a game. So this game is yeah, just like we have some kind of a poison. If we have a poison, so the character will be frozen in a range. So for example, in this range, the character yeah, will be frozen. Yeah, I think we call it in games, we call it sprite, or we call it something. Yeah, but this character will be frozen. Maybe after some time, this character can still, yeah, be not frozen, but we can still attack that. If we attack that, this character will be frozen, maybe next range and next range. So let's first try to understand it. So the Teemo is attacking an enemy S with precision attacks. So the Teemo attacks S gets precision for the exactly duration seconds. So more formally, attack at second t. So for example, this is second t, will mean SC is poisoned during the inclusive time. So this is inclusive. So this is t, and this is t plus duration minus 1. T plus d duration minus 1. Yeah, and this point is also included. So if Teemo attacks again before the poison effect ends, but for this character, if it is still poisoned, so if we attack again, so it will become the next range. It will be like that. Yeah. So it seems there will be some overlap areas. Yeah. So the timer for it is reset, and the poison effect will end duration seconds after the new attack. Yeah, so the poison effect will end duration seconds after the new attack. So this is the new neck attack soon, maybe T1 or T2, T prime 2. So the duration gonna be still the duration, so it's gonna be this kind of range. Yeah, but there's overlap areas, but it doesn't matter because we just need to return the total number of seconds that SC is poisoned. Even here, there are overlaps, but it is okay because it is still poisoned. So we just count 1. Yeah. So this means why we can solve it directly using difference array. We just need to check what is the overlap areas. So for example, the overlap areas is this one. So we just need to check the length of it. Maybe there's another one. So maybe this is 5 and this is 3. We just need to sum up all the overlap areas. Yeah, sum up all the values. So we can use indirectly we can use a difference array to solve the problem. Yeah, but this problem may be a little bit harder because we don't know the maximum add precision. We have to calculate that, and the calculation should be easier. It is just be the maximum of time series plus the duration. So for this one, it's gonna be the maximum add precision we're gonna have. Yeah, but for our calculation, the add precision gonna be t plus duration minus 1. So this means for us, while preparing the difference array, it's gonna be the maximum plus 1, not plus 2. If you use plus 2, it is still okay because for difference array you can still solve the problem, but for exactly calculation it's going to be +1, because the add precision it's gonna never be a t plus duration. Yeah, actually it's going to be t plus duration minus 1, but for difference array we need 2 plus 1, because we need to prepare the next precision, because after this precision it's going to be t plus duration. So this is why we're going to use duration here, and we're going to +1 for the difference array. Now we can directly use the difference array to solve it. So for any time t inside the time series, we're going to prepare a start and add precision. So the start is going to be t, and the add precision is going to be t plus the duration minus 1 according to the formula. Now the f with the start precision going to be plus equal to 1, and f with add precision plus 1 going to be minus 1. Now we're going to check the prefix sum. So it's going to be the list of accumulate with the f. Yeah. Now we just need to check how many overlapping areas. So it's going to be sum with value more than 0 for this value inside the prefix. Yeah. Now let me just submit it and just check it and submit it to check if it works. As you can see, it works. So the time might be a little bit slow, but I think still it is okay, because we are using the difference array to solve the problem. Because of this kind of a duration, it can be really large, 10 to the power 7. So while we are using difference array to solve this problem, definitely it consumes the time, because we are using this 10 to the power 7 as our maximum number. Yeah, if this number is going to be smaller, maybe it's going to be fast. Yeah, but this is why we are using difference array to solve it. But definitely there are other ways you can solve it. Maybe, yeah, the time complexity can be reduced by like n log n time, yeah, or O(n) time directly. I mean, n is 10 to the power 4. But for this one, I used the 10 to the power 7 just to explain. We can use this difference array pattern to solve the problem. Yeah. Now let's continue. Let's continue to solve the next one. It is 1854. So let's check the 1854. 1854. Yeah, it's going to be the maximum population year. So for this problem, we are having array logs, and the logs will be the start and add for a person. So this is the born of a person and the death of a person, but this add year will not be included. We have to be careful about that. We're going to return the earliest year with the maximum population. So for example, this is the person born from this year and dies at this year. And there's another, maybe I'm going to use a circle to explain this dot is not included. And then we're going to have another one, so this dot is not included, but this dot is included. Yeah. We just need to check the maximum overlap areas. Maybe here it's going to be this year. Yeah, we just need to check the starting point. So from here, so it's going to be 3, and maybe the overlap is going to be 3. Maybe this year is 1993. Yeah, so we're going to just return this 1993. As you can see, we can directly solve this problem by using difference array, because difference array is just to calculate the maximum overlap numbers. So maybe the maximum overlap is 3. Yeah. Let's just check the maximum of the dense. It's going to be 2050, but this dense is not included. So this means for the difference array, we can use this number plus 1. So it's going to be 2051. Now we're going to check start and add inside the logs. So start going to plus equal to 1, and add as it is not included. Yeah. So we don't need to plus 1 because it is not included. We have to be careful about it. So if it is included, we're going to plus 1. But if it is not included, we don't need to do that. So we're going to calculate the prefix sum. It's going to be the list accumulate with the f. Yeah. Now we need to return something. But before that, let's just check the maximum overlap. It's going to be the maximum of prefix sum. Yeah. Now we just need to check, let me just delete this one. Now we just need to check which year we have the maximum overlap. So for I, n in enumerate the prefix sum array. So if this n is the maximum number, so we can directly return this year. This year will be the index because we prepared the difference array, and its index will be exactly its year. So we can return this index directly. Now let me just run it and submit it to Tag. So the time complexity is going to be O(n). N going to be this number, 2000. Yeah, as you can see, it works and it's pretty fast. Now let's just continue to the next question. So it's going to be range addition. It's going to be 1400. I think it's going to be 1400. So let's go to 1400 for this problem. It's not 1400. Yeah, it's not this one. Let me check. Yeah, it's not 1400 because this this number is just for the reading for the problem. As you can see, this is a small number. It means this problem is going to be easy, and if the reading is higher, this means it is harder. As you can see, I make it in increasing order. It means the problem will become harder and harder, but it will still be the same pattern. If we use the same pattern, actually, all those problems will be the same. But if you use a different method to solve the problem, maybe the reading for the problem will be different. It will be harder and harder. But for difference array, actually, all those questions will be, the same level. Yeah. Now let's just continue to 370. Yeah. So this one gonna be the range addition. So the idea is that this problem gonna be exactly like the difference array. We just needed to calculate the range sum of all the intervals. So for example, this is from 1 to 3, it's going to be plus 2, 2 to 4, it's going to be plus 3, so here it's going to become 5, and this is going to be 2. And the final one, 0 to 2, going to minus 2, it's going to be minus 2 here. So this is going to be the final array. We just needed to return the final array. So the return time going to be a little bit different. Before, we just return a number. Currently, we can return an array. But it's exactly the same idea. We can directly use difference array to solve it. Before that, we need to check what is going to be the maximum add index. So it's going to be the less than the length. Yeah, so the maximum add index is going to be less than the length. The length is going to be 10 to the power of 5. Yeah, but for this problem, as we are going to return an array, so we don't need to take care about all those. We just need to take care of the length of the array. Yeah, because the start and the add placing gonna always be included. So let's just prepare the difference array first. So it's gonna be the length plus 2. Yeah, because the end placing gonna be included. Yeah, let me check whether it is a plus 2 or plus 1. So this is the length is 5. Yeah, so it means we're gonna return an array. The length is gonna be 5. So yeah, this means the length is gonna be plus 1. Definitely, we don't have the range like 1 to 5. As you can see, it is 2 to 4, but there's never have a 2 to 5 because this 4 and 2 is just the index. Yeah, this is just the index. So this means the length is gonna plus 1. Now let's just use the same idea to solve the problem. So I'm gonna use the start and add. And I'm going to use a counter, maybe capacity. Maybe I'm going to use C as a counter. So inside the updates, so fs gonna plus equal to this counter, and fe plus 1 gonna minus equal to this counter. Now I need to check the prefix sum. It's going to be the list of accumulate with ZF. Finally, I just need to return the prefix sum, but I need to delete the last value because this is just prepared for calculation. For the final return, I just need to return 0 times the length because the last one is just for calculation. After that, the last value is going to become 0. So for example, after calculation, everything will be okay. This is our return, but here going to be a 0. This 0 is just for calculation. Maybe here is a minus 1. Before there is a 1, so 1 plus a minus 1 is going to become 0. but we don't need to return this value, so this is why. Now let me just check it and submit it. As you can see, it's pretty fast and it works. Yeah, and this is the ON solution, and it's the length. The length is just this number 5. Yeah, it is the length of the array actually. Now let's just continue to solve the next one. Maybe. Yeah, I think I have deleted. Yeah, I think let's just continue to solve the next one. This one gonna be the carpooling 1094 carpooling. So 1094. Yeah, so for this problem actually it's also the same. It just tells you there are some positions. So if this position is the car's position, start and end position, there's another car pulling at here, because it will always be pulling at one line. It will be like that. Yeah, maybe here is another one. We just need to check the capacity. This car pulling is just needed to pick up the passengers from 2, because like for here we pick up passengers 3, and for here we drop off, it's going to be -3. Maybe here we're going to pick up 2, and here we're going to drop 2 person. It's going to be like that. Yeah, so this is going to be the idea of the problem. But we have a capacity. This means the car have a capacity of 4, but for here 3 plus 2 is going to be 5. So if this value is more than the capacity, so we're going to return false, otherwise we're going to return true. Yeah, as you can see, this is going to be exactly the difference array idea. So now let's try to solve it. So we're going to prepare a difference array. It's going to be 0 times the end position. Let's just check the end position. It's going to be 2 from 2i and 1000, but we're going to use the end position is also inclusive, because this from 2 is also this 2 is not inclusive, because from this 2 we're gonna drop off. We're gonna drop them off. So we pick up and drop off from and 2 respectively. This means we're gonna drop off this person, so we don't need 2 plus 2. We just needed to use 1001, because this is gonna be the maximum value of 2 going to be 1000. We just need 2 plus 1. Yeah, because we're going to drop off at the end position. So for count, start and add inside the trips. So the start gonna plus equal to the capacity, and the end we're gonna drop off. So we're gonna directly use FE minus the capacity. Now we're gonna check the prefix sum, and it's gonna be accumulate of the F. Finally, we just need to return the maximum of the prefix sum. If it is less than the capacity, we're gonna return true. Otherwise, we're gonna return false. I should not use the array outside. It is just a number. Yeah, now let me just submit it to check. Yeah, as you can see, it works and it's pretty fast because this is just an ON solution. Now, let's just continue to solve the next one. It's gonna be the corporate flight booking 11 and 9. 1109. Yeah, so for this one, let's just check this one. Yeah, if we are reading about this problem, corporate flight bookings, we just needed to book something. The book I is just the first, last, and seats. So this is the first, last, and seats, and this is another first flight, last flight, and seats, and this is continuous. So this is why we can directly use a difference array to solve it. So for example, this is the first and this is the last. We're gonna order 5. This means from here plus 1, we're gonna use a minus 5 for the difference array. For another one, maybe we're gonna order 3, but for the add placing plus 1, it's gonna be here, it's gonna be a minus 3. And finally, we're gonna accumulate all the values and we're gonna return this array. Yeah. So like the previous question, for this one, we also return an array, but we're gonna use a difference array directly to solve it. Yeah. So it's gonna be 0 times the number, and we have this total number of flights. So this n, yeah, gonna be the flights. So they are labeled from 1 to n. Yeah. But if we are going to order this flight n, definitely we need to use n plus 1. Yeah. But we are starting from 1 to n. This means we're gonna use n plus 2. Yeah. So definitely for this array, so for example, we have an array, something like that. So this array gonna be the length of the array gonna be 5. So this is n plus 2. 1, 2, 3, 4, 5, 6. We need another 0. Yeah. But we just need to return in between. We don't need to return the first one because this is not the flight according to my definition of the problem. Of course, you can also use this one, but for me, I don't use it because this is easier for coding, and I will not include the last one because this is just for calculation. Yeah. Now let's just check. So for the start and capacity inside the bookings, so the start would plus equal to 1, and the end, as the end is included. Yeah, so as you can see here, it is inclusive. Yeah. So represents a booking for flights first I through last I inclusive. Yeah, as you can see, this is inclusive. So it means the e plus 1 gonna be minus 1. This gonna be the start, gonna be plus the capacity and minus the capacity because we are going to return an array with the capacities. Yeah, with all the total number of seats reserved for flights for each of the flights. Now we can calculate the prefix sum. It's going to be the list of accumulate of f, and finally we can return the prefix sum, but we need to remove the first and the last in the prefix sum array. Yeah. Now let me check that and submit it. Yeah, as you can see, it works and it's pretty fast. Yeah. Now let's just continue to solve the next one. So the next one gonna be, yeah, the next one. I think I didn't miss anything. I think I solved this one, this one, this one, and this one. Yeah. So the next will be the meeting room, 255, 252. So it's gonna be 252. And 253. Yeah, so let's first check this 252, the first meeting room. Yeah, so this is just to determine if a person could attend all meetings. So all the meetings will be such kind of intervals. We just need to check if there's overlap or not. If there's overlap, so the person cannot attend the meeting. If there's no overlap like that, so definitely it can attend all the meetings. Yeah, but we need to check the start and the end placing. So for example, this is 2 to 5, 2 to 3, maybe this is 3 to 5. So this means this person, if there's an overlap with the start and end, definitely the person can attend the meeting. Yeah, because this 3 is not included. Even it is not mentioned inside of the question, but as a tradition, we're gonna understand at the end time is that will not be included. Otherwise, we cannot solve it. Yeah. So this is add time will not be included. Yeah. So definitely we're gonna use a difference array to solve it. We just needed to check. So if all the values is less than and equal to 1, definitely it is true. If any kind of value we find it is more than 1, it's gonna be a false. Yeah. So let's just use the difference array to solve it. So it's gonna be 0 times 10 to the power of here, the end I is going to be the 6. As the end place is not included, so we're going to use plus a 1. Now we just need to check the start and add inside the intervals. So the f start would plus equal to 1 and f add. As this is not included, we're going to use the add directly, minus of 1. Now we're going to check the prefix sum. It's going to be the list accumulate of the f. Finally, we're going to return the maximum of the prefix sum. So if it is less than or equal to 1, it's going to be true, otherwise it's going to be false. Now let me check that and submit it. Yeah, as you can see, it works. It is not fast because we are using difference array, and this is 10 to the power of 6. Definitely you can use the sweep line, it's going to be n log n time, it is much faster. Or you can use greedy ideas. But for this topic, I just want to explain the difference array. Even though the time complexity is not the best, but the idea is just for the pattern, the difference array pattern. Yeah. Now let's just continue to solve the next meeting. So I'm going to use exactly the same code. So I copied it from the previous one. I just needed to change a little bit. Yeah, because for this question, the return going to be the minimum number of conference rooms are required. So let's just check that. So this is going to be the meeting rooms. We just need to check the overlap areas, maximum overlap numbers. So for here, the maximum overlap, like here, it is a 3. So if it is like that, we're going to return a 3. For here, it is a 2, but the maximum going to be 3. So like this way, we can use a difference array to check the maximum overlapping areas. Yeah. So for the same problem, I will not write the code. I just copied it from the meeting rooms 1 by the difference array pattern. So after checking the prefix sum, I just needed to return the maximum of the prefix sum array because this is going to be the maximum overlap areas. Yeah, the maximum overlap numbers just means the minimum conference rooms required. Yeah, so let me just run it. Yeah, because this is the maximum prefix sum. Let me just submit it. Yeah, as you can see, it works. It's not fast because we are using this kind of a difference array. It is 10 to the power 6. If you were to make it fast, you can use n log n. It's going to be 10 to the power 4 times log 10 to the power 4. It's going to be much faster. So that's going to be the greedy idea, or that's going to be the sweep line. You can make it faster, but that will be the next topic. But here we're going to focus on the difference array. It is a 1D difference array, and this array is also contiguous difference array. I mean, this array is contiguous. It is not separate. It is not separate. It is not discrete. It is contiguous in an array. Yes, that is why it is so slow. But that's going to be the basic pattern. Yeah. I think I've already submitted. Let me just double check. Yeah, it should be okay. Now let's just continue to solve the next one. So the next one gonna be the last one. Divide intervals into minimum number of groups. So it is 2406. Yeah, let me just go to 2406. 2406. Yeah, let's first try to understand it. So we are giving a 2D integer array intervals. So the left and right, and the interval is inclusive. So the inclusive left and right. So you have to divide the intervals into one or more groups such that its interval is in exactly one group. And no two intervals that are in the same group intersect each other. So the idea is that we are giving an array of intervals. Yeah. Basically, we want to put it inside the different groups. So for example, for this one, yeah, for this one, we're gonna put it into 3 groups. So this is just for checking the maximum overlapping area. So for here, for example, at this present, the maximum overlapping gonna be 3. Yeah, so if we are going to calculate something like that, so it is like the previous problem, meeting rooms 2, the minimum meeting rooms required. But for this one, it is the minimum number of groups required. It's exactly the same question. So we're going to use the same pattern to solve the problem. Yeah. Now let's just check the right position. It's going to be the 10 to the power of 6. As it is inclusive, so we're going to use f0 times 10 to the power of 6 plus 2 because it is inclusive. So for start and inside the intervals, so the start gonna plus equal to 1, and the add inclusive, so we're gonna plus 1 minus 1. Finally, we're gonna check the prefix sum. Yeah. So we're gonna check the prefix sum. Finally, let's check the maximum of the prefix sum. So it's gonna be the minimum number of groups. Yeah. Now let me just run it and submit it. Yeah, as you can see, it works. I think the speed is also okay, because definitely this n is 10 to the power of 6 and it is ON. Yeah. I think there's also another way, it is n log n. It is 10 to the power 5 log times log 10 to the power 5. Maybe this number is bigger than 10 to the power 6. Yeah, maybe for this problem, it's better to use a difference array. As you can see, the coding is, yes, just so easier. It's just a very simple pattern, because we didn't do any analysis. We just used the pattern to solve the problem. Yeah. Now I think we've solved, we explained 10 questions about this difference array pattern, and this is 1D contiguous difference array, and there's also 1D discrete difference array. Yeah, but for this one it is contiguous, so I forgot to write about it. I think that's for it for today's pattern. So see you next time. I will prepare more Leetcode patterns like this.